In this video, we will see a short introduction to direction cosines and direction ratios, and further we will move on to some of its properties and results. So let P be a point in the space with coordinate x, y, and z. So you have P as a point in space with coordinate x, y, and z, and of distance r from the origin. So its distance from the origin is given to be r. Let R, S, and T be the foots of the perpendiculars drawn from P to the x, y, and z axis. So what do they mean by that is you're drawing perpendicular lines from P all the way to the x-axis, and it reaches the x-axis meets the x-axis at R, and it meets the y-axis at S, and the third perpendicular from P meets the z-axis at T. So that means your angle P or O will be 90 degrees and PSO will be 90 degrees, and your angle PTO will be 90 degrees. And the length OR is defined as X as XYZ or the coordinates, and the length OS will be Y, and the length OT will be Z. And we know that the length OP is given by R. Now, it may be slightly hard to visualize these triangles because as they are in a three-dimensional space. To help you understand the three-dimensional aspect of these angles and the direction cosines, you can find a link video in the description box down. If you're interested in getting a deeper understanding, you can watch that and get a clear understanding of how these angles are placed in the three-dimensional space. Right. Let alpha, beta, and gamma, so you have alpha, beta, and gamma, be the angles made by the vector OP with the positive x, y, and z axis respectively. So these are the angles that it makes with the x, y, and the z axis. I mean the vector OP makes with x, y, and z axis, and therefore your angle POR, which is POR, is alpha, POS is beta, and POT is gamma, which you can see in this triangle that POR is alpha. Now, so in the triangle OPR, our angle PRO is 90 degrees, and the angle POR is alpha, and OR is X, and OP is R. So we can define cos alpha as OR by OP, so adjacent side by hypotenuse, which is X by R. Similarly, we can find for cos beta and for cos gamma to be Y by R and Z by R respectively. Here the angles alpha, beta, and gamma are called the direction angles of the vector OP. So the angles alpha, beta, and gamma are described as the direction angles of the vector. And cos alpha, cos beta, and cos gamma are called the direction cosines of the vector OP. So cos alpha, cos beta, and gamma are the direction cosines. Therefore, we already found the direction cosines to be x by r, y by r, and z by r. So this set is called the direction cosines of the vector r is equal to xi cap plus yj cap plus zk cap, where r is equal to square root of x squared plus y squared plus z squared. Further, any three numbers which are proportional to the direction cosines of vector are called the direction ratios of the vector. Hence, the direction ratios of a vector are not unique. For a given vector, we have definitely many sets of direction ratios. So any three numbers which are proportionate to the x by r, y by r, and z by r are called the direction ratios. Further, let us see some results and properties of these direction cosines and direction ratios. So the first thing that we will see here is that the sum of squares of the direction cosines of r is 1. So what does this mean? So direction cosines are cos alpha is equal to x by r, cos beta is equal to y by r, and cos gamma is equal to z by r. So the squares, the sum of the squares, so cos squared alpha plus cos squared beta plus cos squared gamma will be equal to x squared by r squared plus y squared by r squared plus z squared by r squared. Simplifying further, we will get this as r squared as the denominator, and the numerator will be x squared plus y squared plus z squared. We know that x squared plus y squared plus z squared is equal to r squared. So this is equal to r squared by r squared, and that is equal to 1. So that proves our first property or the result of direction cosines. The second result says that sine squared alpha plus sine squared beta plus sine squared gamma is equal to 2. Now we know that sine squared alpha can be written as 1 minus cos squared alpha. So let's replace sine squared alpha as 1 minus cos squared alpha. Similarly, sine squared beta can be written as 1 minus cos squared beta, and sine squared gamma can be written as 1 minus cos squared gamma. That would be, this is our LHS. So this will be equal to 3 minus cos squared alpha plus cos squared beta plus cos squared gamma. We have seen already that the sum of the squares of the direction cosines is 1. So this is equal to 3 minus 1, and that's equal to 2. And hence our proof. That's our RHS. Hence the proof. The third result says that the direction cosines of vector r are x by square root of x squared plus y squared plus z squared. Similarly, the other two. Now, we can say that our direction cosines, which is cos alpha, cos beta, cos gamma, are expressed as x by r, y by r, and z by r. Now, we know that r is equal to square root of x squared plus y squared plus z squared. So replacing this, we can say x by square root of x squared plus y squared plus z squared, comma y by square root of x squared plus y squared plus z squared, z divided by the square root of x squared plus y squared plus z squared, or our direction cosines. The result 4 states that if L, M, and N are the direction cosines of the vector, if and only if L squared plus M squared plus N squared is equal to 1. So if L is equal to cos alpha, M is equal to cos beta, and N is equal to cos gamma, then L squared plus M squared plus N squared is equal to cos squared alpha plus cos squared beta plus cos squared gamma. And we know that this is equal to 1. We have already proved this in our result 1. Therefore, our LHS is equal to RHS. Hence the proof. The last one says any unit vector can be written as cos alpha I cap plus cos beta j cap plus cos gamma k cap. Now, the coordinate of this vector will be cos alpha, cos beta, and cos gamma. We know that cos alpha is equal to x by r, cos beta is equal to y by r, and cos gamma is equal to z by r. So if this is our coordinate, then the length of this vector would be square root of cos squared alpha plus cos squared beta plus cos squared gamma. We already know that the sum of these is going to be 1. So this is square root of 1 and that is 1. So this is a unit vector. Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.